acids, bases, and salts. In our main focus for today, we're going to discuss acids. Okay? And under acids, things that we're going to look at. So number one, we're going to define an acid. Number two, we're going to look at types of acids. Number three, we're going to look at ionization of acids. Then number four, we're going to look at strength of an acid. Okay? And then number five, we're also going to look at the physical and chemical properties of acids. Okay, so under acids, these are the things that we're going to discuss for today. So we'll start with defining what an acid is. So when we talk of an acid is simply a substance that produces hydrogen ions when dissolved in water. I'll repeat that. An acid is a substance that produces hydrogen ions when dissolved in what? In water. So in simple terms, what we mean by an acid, when you get an acid and you dissolve it in water, it is going to produce what we are calling hydrogen what? Hydrogen ions. And these hydrogen ions are going to be positively what? Charged. Let's take for instance, we have an acid which is HCl. This acid is hydrochloric acid. If we dissolve hydrochloric acid in water, it is going to produce hydrogen what? Hydrogen ions plus chloride what? Ions. But our main focus is here where the hydrogen ions are being what? Produced. So if you get an acid and you dissolve it in water, what you are going to produce are the hydrogen what? Hydrogen ions. Let's take for instance, we have sulfuric acid. If sulfuric acid is dissolved in water, it is going to produce 2 hydrogen ions plus a sulfate what? Sulfate ion. Our main focus, remember, we are producing hydrogen what? Hydrogen ion. So this proves to say, if you get an acid, you dissolve it in water, you are going to produce hydrogen ions. Are we together there? So that's what we mean by an acid. So an acid is a substance that produces hydrogen ions when dissolved in what? Dissolved in water. Okay, we move on. We move on to the types of what? Types of acids. So when we talk of the types of acids, there are 2 major types of acids, namely, so number one, we have organic acids. Okay. Number 2, we have inorganic acids. Inorganic acids are also known as mineral acids. So you need to know the difference between these 2 types of acids. So we have 2 types of acids, organic acids and inorganic acids, which are also known as mineral acids. So remember, where you are seated, get a book and a pen, you are drawing down the notes as I am explaining. So let's start with organic acids. So what do we mean when we say organic acids? Organic acids, these are acids that are naturally found in plants and animals. So these acids, they are naturally found in plants and what? Plants and animals. For example, we have acids such as citric what? Citric acid. Citric acid is an organic acid which is found in citrus what? Citrus fruits. An example of a citrus fruit is a what? A lemon. A lemon. So the type of acid which is found in citrus fruits, for example, a lemon, it's citric what? Citric acid. Okay? So citric acid is an organic what? Organic acid. Another example of an organic acid, we can give an example of ethanoic acid. Okay? So ethanoic acid is an organic acid which is found in vinegar. Okay? Another organic acid we have is lactic acid. So lactic acid is an organic acid which is found in sour milk. So these are some of the examples that we can give under organic acids. So remember, organic acids, these are acids which are naturally found in plants and what? Animals. For example, we have citric acid in citrus fruits, ethanoic acid in vinegar, lactic acid in sour milk. Okay, we move on to inorganic acids. What do we mean when we say inorganic acids? So inorganic acids, these are acids that can be obtained by carrying out chemical what? Chemical reactions. These are acids that can be obtained by carrying out chemical reactions. For example, we have nitric acid. So nitric acid is an example of an inorganic acid because for you to make nitric acid, there are certain chemical reactions that you need to carry out in the process known as the Oswald process. Okay? Another example that we can give is sulfuric acid. Sulfuric acid is also an inorganic acid because there are certain chemical reactions that take place in order to make sulfuric acid. Okay? Another example that we can give is hydrochloric acid. So hydrochloric acid is also an example of an inorganic acid. Okay? So remember, organic acids are acids naturally found in plants and animals, and these are some of the examples. Inorganic acids, which are also known as mineral acids, these are acids obtained through chemical reactions, and these are some of the examples. Okay? So, looking at types of acids, we move on to the third part, where we are going to look at ionization of acids. Okay. So, alright. So the third part, we are looking at ionization of acids. When we talk of ionization of acids, let's first understand the word ionization. So ionization is simply the process by which ions are formed. Ionization is the process by which ions are formed. So when we get an acid, we dissolve it in water, it produces ions. Right? For example, if we have hydrochloric acid, we dissolve it in water, what are we going to produce? We are going to produce hydrogen ion plus chloride ions. Since this reaction involves the production of ions, we can say this is an ionization equation for hydrochloric acid. Remember, ionization is the process by which ions are formed. For an acid to form ions, it has to dissolve in water. So, if you look at this example, we have hydrochloric acid. When we dissolve it in water, it is producing hydrogen ion plus chloride what? Ions. So these two are ions. So this is an ionization equation for hydrochloric acid. So if a question comes in an exam to say, write the ionization equation for sulfuric acid. Okay? So for you to write the ionization equation for sulfuric acid, since it is an acid, for it to undergo ionization, it has to dissolve in water. when it dissolves in water, it is going to produce 2 hydrogen ions plus sulfate ion. So this is an ionization equation for sulfuric acid. Alright, let us look at the last example. If we have nitric acid, write the ionization equation for nitric acid. If nitric acid dissolves in water, we are going to produce hydrogen ion plus nitrate ion. So these are what we call ionization equations of what? Acids. So you have to remember, if an acid dissolves in water, it produces ions. Alright. We move on to the 4th part. Strength of an acid. Strength of an acid. So strength of an acid, that is the 4th part. So when we talk of strength of an acid, we simply mean the ability of an acid to dissolve in water. So according to strength of an acid, there are 2 types of acids. Number 1, we have strong acids. Then number 2, we have weak acids. So these are the 2 types of acids according to their strength. So let's start with strong acids. So when we talk of strong acids, these are acids that ionize completely when dissolved in water. I'll repeat that. Strong acids, these are acids that ionize completely when dissolved in water. What do we mean? When an acid is dissolved in water and it ionizes completely, that acid is a strong acid. For example, we have hydrochloric acid. If hydrochloric acid is dissolved in water, it ionizes completely. It will form hydrogen ion plus chloride ion. So hydrochloric acid is an example of a strong acid. Another example is sulfuric acid. Sulfuric acid is a strong acid. When it is dissolved in water, it ionizes completely. It is going to form 2 hydrogen ions plus sulfate ions. The 3rd example is nitric acid. So nitric acid is a strong acid. When it is dissolved in water, it will produce hydrogen ions plus nitrate ions. So we have 3 examples of strong acids: hydrochloric acid, sulfuric acid, and nitric acid. Alright? Let us look at weak acids. So weak acids is just the opposite of strong acids. These are acids that partially ionize when dissolved in water. Weak acids, these are acids that partially ionize when dissolved in water. What do we mean? Let's look at an example. Ethanoic acid. So when ethanoic acid is dissolved in water, it ionizes partially. So for us to show that it ionizes partially, we are going to use 2 arrows to show that this acid ionizes partially. It will be reversible. What are we going to form? We are going to form hydrogen ion plus CH3COO negative. So these 2 arrows here, they help us to say this acid is a weak acid. It ionizes partially. Alright? Another example that we can look at is carbonic acid. So carbonic acid, we have H2CO3. When it is dissolved in water, it ionizes partially. It will produce 2 hydrogen ions plus carbonate ion. Since we have 2 arrows here, it is telling us to say it has ionized partially. So these are the 2 types of acids according to them. Alright, so we move on to the physical and chemical properties of acids. So we are going to start with the physical properties of acids. Okay, so the physical properties of acids. So number 1, acids have a sour taste. So acids, they have a sour taste. Number 2, acids turn a blue litmus paper to red. Acids, they turn a blue litmus paper to red. So when we talk of a litmus paper, it is an indicator which we can use to differentiate acids from bases. So if we get a blue litmus paper and then we put this litmus paper in an acid, it will turn, or it will change the color from blue to red. Alright, so acids turn a blue litmus paper to red. Then number 3, acids have a pH value of less than 7. Acids have a pH value of less than 7. So if you go on a pH scale, or if you use a pH scale and you want to know the pH of a certain substance, if its pH is less than 7, then it means that substance has properties of acids. If we were to draw a pH scale, it looks like this. So it has numbers running from 0 up to 14, and in the middle we have 7. So from 0 to 7, it shows alkalinity. It shows acidity. And from 7 to 14, it shows alkalinity. So if the pH value of a substance is below 7, then that substance has properties of acids. Okay? So acids have a pH value of less than 7. Alright. Alright. So we move on to the chemical properties of acids. So number 1, acids can react with metals to produce salt plus hydrogen gas. An acid can react with a metal